Hello, my name is Rodion Simogatulin, and today I'm presenting my project titled The Limits of Control over Neural Networks. This topic is especially relevant today, as AI is already shaping our daily lives and even the future. Let's take a look at how AI sees the world. You might think AI sees like we do, but that's not the case. Neural networks doesn't see the world like humans do. They simplify everything into lines, patterns, and shapes. You can ask me why. Because this is easier to convert into numbers. And for a neural network, numbers are everything. Any image, sound, or word becomes just data. Here's a visual example. On this slide, you can look how we see the astronaut. Detailed, colorful, familiar. On this slide, you can look how an AI sees the same image, a simplified version made up of edges and shapes. It doesn't recognize an astronaut the way we do. Let's look at one more example, this time a car. On left, you see a photo of the car, the brand, the model, the color. But on the right, this is how an AI sees the same car. Just like before, the image is reduced to lines, shapes, and key features. This transformation helps an AI understand, compare, and respond, not with thoughts, but with calculations. So, how do neural networks actually work? At their core, neural networks convert one type of data into another. For example, they can turn text into an image, convert an English voice into a Russian voice, or even transform brain signals into movements of a robotic arm. These transformations are called functions, and in fact, any process in nature can be described using functions. That's why neural networks are so powerful, because the world is full of functions. Let's take an example from nature. A thunderstorm is also a function. The input is a friction between water and air. The output is lightning. Nature transfers inputs into outputs, just like a neural network does. Almost everything in our world is made of numbers, and almost every process can be described as a function. That's why neural networks are so powerful. Mathematically, they can solve any task that can be expressed as a function. In theory, it makes them almost omnipotent. What you see here is a basic neural network. Each neuron is like a small formula. These neurons are arranged in layers, and the layers exchange information step by step. Thanks to the structure, neural networks can solve very complex problems, but always one step at a time. Let's talk about the real cost of intelligence. Not money, but computing power. For example, to run a video game like Cyberpunk, you only need one mid-range graphics card. But to create something like ChatGPT, it takes over 30,000 GPUs just to bring it to life. And that's just at the beginning. To produce even a simple human-like thought, the model needs 117 million neural connections. To talk about ecology or global issues, it requires 8 billion connections. And to understand physics or develop a sense of humor, it takes over 220 billion neural connections. Intelligence isn't a magic, it's a massive computation. The truth is, AI developers are moving in the dark. They often create neural networks first, and only later discover what they are truly capable of. That's why so many news outlets, scientists, and public figures are sounding their alarm like AI might one day slip out of control. The nature of AI is that its final results are almost impossible to predict. And with today's computing power, AI systems are already capable of making auto decisions. But what happens when we increase that power by 100 or even 1000 times? then AI might be able to cure disease, or it might just be able to destroy our world. The risk grows with the power. Humans created artificial intelligence, and in terms of development, it's still like a kid. It raises a big question. How do you teach an AI to see and think in the real world? Well, you already help by solving a CAPTCHA. CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart. When you click on traffic lights or crosswalks, you aren't just proving you're human. You are actually training Google's AI to recognize images. Little by little, we gave it vision. What if we train a neural network that receives as input not the road signals and the street views, but our faces? Back in 2018, people discussed that with the right makeup, none of AI won't recognize you. But today, it doesn't matter anymore. Now, modern AI scans your face using infrared light. It doesn't care about makeup, shadows, or even skin color. These technologies now allow drones to create detailed 3D models of entire cities for Google Maps. As a result, our cities are becoming smart and convenient, but also transparent. There is nowhere left to hide. There is a special kind of neural network works like a digital compressor. It's called an autoencoder, and it has two parts. The first part is encoder. It compresses the image based on learned rules, for example, by detecting key features like shape, position, and color gradients. The second part is a decoder. It uses those same rules to rebuild the original image from compressed data. When trained on millions of faces and portraits, the network learns how to compress a face into digital noise, and then reconstruct it back into something fully recognizable. But here is the twist. We can actually remove the encoder entirely. All that's left is the decoder. And now, instead of uncompressing an existing image, it can generate completely new ones from scratch. Sounds like magic, right? But we hit a limit, a law of physics. The second law of thermodynamics. You can't get something from nothing. So, we must give the neural network something to start with. And that something is digital noise. Random pixels. We feed noise into the decoder, and because it has learned the rules of human faces, it reshapes that noise into new, realistic portraits. It doesn't remember specific people, it understands what a person looks like, and builds one from chaos. Language models like ChatGPT, DeepSeek, and others are about to change education, just like the internet once did. For a language model, school and a college aren't that different. In both places, students are often struggle, either because of the material is too boring or because it's too hard. The sweet spot for learning is in the middle, not too easy and not too difficult. But in a classroom of 30 students, 5 don't engage at all, 10 excel effortlessly, and the remaining 15 are trying to catch up. That's because every student is different, but the assignments are the same. A person AI tutor could change that. It could adjust to each student's level and still teach what the teacher wants, but in a way that fits the individuals. Language models like ChatGPT are the closest thing that can reach to artificial general intelligence, or strong AI. There is no longer solving narrow tasks. They are learning across many domains, just like a human. By turning all our text into numbers, we are giving those models access to human culture itself. But here's the scary part. When we create an AI, we don't fully know what we are creating. The one day its goals may not to match ours. And if something goes wrong, many believe we could just pull the plug. But the most important goal for an AI is not to be turned off. It might sound like a problem for the future, but when they finally build a true general intelligence, there will be no undo button. We have only one chance. What if we don't want to turn an AI off? What if it makes our life so convenient that we willingly give up our free will? Sounds extreme, but think about this. Who still uses a compass or paper map? We trust Google Maps to lead us everywhere. Quickly, easily, instantly. The same thing is happening everywhere. What to watch, who to date, what to read, even what to believe. We make like 35,000 decisions every day, and many of them are small, routine, or tiring. So why not let AI decide? But each time we let go, we give up our little piece of freedom. Why write when ChatGPT does it better? Why draw when AI art is faster? One day we might get used to something that makes better decisions for us. We won't always understand how it thinks, but we'll trust it anyway. And that's why the future is already here. It's just time to notice it. And thank you for watching.